everybody. Welcome to the new series of TensorFlow. Earlier, maybe a year or more, I have already put TensorFlow, but that was something old, and TensorFlow has grown up, and so the platform also. Now you can even work on cloud without any good PC if you have, and you can work on TensorFlow and you can create your solutions. So what is TensorFlow? TensorFlow is basically an end-to-end open source machine learning platform. Now what is machine learning? Machine learning is a part of AI where you train your machine to learn. Actually, it is different kind of neural networks which you have created as models, and you are training those models. So TensorFlow provides you a platform where you can deploy, develop, etc. your models. Now in TensorFlow, you can use GitHub where you have some models which are already created. You get a community. You can sign in with your Gmail account and you can execute your models on cloud. Now, as we can say that now TensorFlow has grown, so TensorFlow we can divide into 4 parts. The core TensorFlow, TensorFlow for JavaScript, where you can develop TensorFlow on your web page, TensorFlow on mobile and IoT, where you can use Android, etc., and you can use it on your mobile. TensorFlow for production, you can use your developed model and you can deploy them in your organization. So before getting started with the core TensorFlow, we should understand why TensorFlow. As I told you, that TensorFlow is an end-to-end open source platform for machine learning. It has a comprehensive, flexible ecosystem of tools, libraries, and community resources that lets researchers push to the state-of-the-art machine learning, and developers easily build and deploy their machine learning powered application. Now, if you are a beginner, you can go simply for you can build and train models easily using your intuitive high learning API like keras, and with eager execution, which makes for immediate model iteration and easy debugging. Okay. You can go for robust ML production anywhere, easily train and deploy models in the cloud, in the browser, or on no matter what language you use. You can go for powerful experimentation for research. You have a flexible, simple architecture to take new ideas, concept. You have to code it, and you can get state-of-the-art models, and you can go for production very fast. So out of these 4 in this episode, firstly we will be talking about the core TensorFlow. Okay, so get started with TensorFlow. So when you go to this site, which is your tensorflow.org, and you are in the overview of the core TensorFlow, you can go for 2 options. Either you can see the tutorials or you can see the guides. Okay, and if you are a beginner, for beginner the best place to start with a user-friendly sequential API. You can create models by plugging together building blocks. We can run the hello block example, which is below. Then we can visit the tutorial to learn more. If you are an expert, you can go for the advanced research, and you can easily go for the custom layers and the activation and training loops. Okay, so let's go for the beginners. Now these code which you are seeing is actually Python. So if you have any idea of Python, you will understand it. Otherwise also, if you are a simple computer guy, you will be able to understand what is this. Even if you know Java, it will make sense for you because object-oriented languages are more or less same. So what we are doing actually in this beginner code, we are simply importing TensorFlow library, and we are having an instance called as TF. You can make any instance, you can give any name. Now when this library is imported, now what we are doing, we are actually getting the data set which is MNIST. Now what is MNIST? MNIST is actually handwritten 0 to 9 characters which we have to go for training to detect 0 to 9 characters, right? So what we are doing actually is tf.keras.datasets.mnist. So we are taking MNIST into this object. So our data set, which is 0 to 9 handwritten data, is now in this. Now what we'll do is we'll train and we'll test. So what we are doing, we are loading data. MNIST dot load data, which we are splitting it into training data and test data. Now xtrain comma xtest is actually xtrain divided by 255, xtest divided by 255. Now we are making a model. We are making a sequential model. So we are taking a model object where tf.keras.models.sequential. So in this, inside we are having 1, 2, 3, 4 layers. What are these layers? They are actually neural network layers. So this is a flattened layer, this is a dense layer, this is a dropout layer, then again a dense layer. This dense layer is having an activation function. This dense layer is having activation function softmax. Okay. So if you have a basic knowledge of neural network, you will understand that. Otherwise, you have to refer the basic neural network. After this model is declared, we'll compile this model. So for compiling the model, we are using one of the optimizer. We can use any optimizer, but here we are using Adam optimizer. And for loss, actually loss is what? The previous and the current. So we go for sparse categorical cross and from, where we are taking the matrix accuracy. Then we are fitting the model. We'll go for 5 epochs. You can go for any number of epochs. Then you can evaluate model. After training model, when this is trained, you can test the model. So what you can do is we can run this code on the Google Interactive Notebook. So what we'll do is go for run code now. So for that we have to log into our Gmail account. Okay. So my system is a little slow, so maybe it will take some time. So those who are familiar with Jupyter Notebook, they will be able to understand. Other people can refer my old this thing. So you can see my Gmail account because it was already logged in, so it is there. So what I can do here is I can run this simply. So what we have seen, so that you can run here. Okay, so you can see here it is simply Jupyter Notebook which is on cloud, right? So what you can do here is you can run this. So firstly you can choose any of these options. So if I say connect to local runtime, so it will be connected to local runtime. If I'll go for connected to hosted runtime, so it is connecting to hosted runtime, which is actually your Google Cloud runtime environment. So it is connecting, it is initializing, now it is connecting. So it is showing some RAM and disk for me, and I can run it. So if I say run all, so it will run these commands one by one. So you can see it is running. So we have taken 5 epochs, so it will run for 5 epochs, and each epoch it will come with some accuracy. You can increase the epochs, and you can, for yourself, you can see in some cases the accuracy goes up and goes down and so on. So it is saying the image classifier is now trained for 98% accuracy after these 5 epochs, right? So this is all about a simple model which we have seen, right? And so you can even run it on Google Colab. You can download this notebook if you want to run locally, right? So that is there. Now, after doing this, if I am simply talking presently about the beginners, so now we come to tutorials. If you are a simple beginner, you can go to the tutorial and you can go for these different basic topics, right? Firstly, we have to talk about TensorFlow and keras guide, because we should know what is TensorFlow and keras. So we'll go to TensorFlow and keras guide. So firstly, what is keras? Keras is actually a high-level API to build and train deep learning models. It is used for fast prototyping and advanced research and production with three key advantages. Firstly, keras is user-friendly because you don't need to code much. If you are not using keras and simply if you are using only TensorFlow library, earlier because keras was not a part of TensorFlow but it merged into TensorFlow. So plainly with TensorFlow you need more code, but with keras simply you need less code. It is modular, it is easy to extend, and I told you simply if you write import tf.keras, so you can import, right? Now if you want to install keras on your platform, if you have a Python platform on your machine, and if you want to import the libraries, you can simply use pip. I hope the Python user they know pip command. Pip install -q py-yaml, where you are saving your models in YAML format. What is the advantage of YAML format? The advantage of YAML format is you can import, export your models anywhere. After that, if you are using your, after installing this, you can simply use your Python commands and you can import TensorFlow, and then you can import layers and you can do with your models. As I told you earlier, firstly we have to talk about sequential model. Okay, so what is a sequential model? In keras you assemble layer to form model. A model is usually a graph of layers. The most common type of model is stack of layers, which is called as sequential. That means one by one you are executing the layers. So if you want to build simply fully connected network, if you are a neural network guy, you will be able to know multi-layer perceptron. You can simply say model object is equal to tf.keras.sequential. Then after, if you have instantiated a model object, then you can add layers with model.add, dense, etc. Okay. Now configure the layers. There are many layers available, but there are some constructors which are available. Activation constructor, kernel initializer, kernel regularizer. Okay, so if I want to create a dense layer, I can go for dense with activation sigmoid. We can write this way also, so both ways work. Now if I want to go for a dense layer with regularization factor of 0.01, then I can write this. Layer 2, etc., etc. Now, after making a model, when you have made a model, if you write model.compile, then actually you are compiling the model, because maybe there are some errors. So you compile model with some optimizer. There are different optimizers available. Presently we have taken here Adam optimizer. So when you go for compiling, in compiling you have to specify three things: optimizer, loss and matrix. Now optimizer, you can go for Adam, RMS or gradient descent. The students who are studying neural network, they can understand this. Okay. Loss. What is loss function? The function to minimize during optimization. Common choices are mean square error, categorical cross entropy and binary cross entropy. Okay. So we have to actually go for accuracy. So we have to minimize loss. Matrix. It is used for to monitor training. Okay, so there you can specify matrix. Now, if you don't have ready-made data sets, then you can simulate a data set with NumPy. NumPy is a library, and with the help of NumPy, you can randomly create something. Okay, and you get data. So this is simulated data, right? Earlier we have talked about MNIST, which is actual data. Okay, so this way you can go for. Here you can see one of the other data set, which is data set from tensor slices. Okay, so that is data set. If you want to build advanced models, you have to go for instantiate model with some inputs, and you have to. The basic is same. The only thing is how many layers you use for that. You can try with different layers. You can use some custom layers and callbacks. Now we come to callback. A callback is an object passed to model to customize and extend its behavior during training. You can write your own custom callback or use built-in keras callback. Okay. Now, if I want to go for something which is other than YAML, normally you save your model as YAML. But if you want to save your model as JSON object, which is more popular, you have to go for JSON string, model to JSON, and you have to save it as JSON. And when you have exported it, you can import it again somewhere and you can use it. So here you can see a total model. You can copy it anytime and you can run it. Okay. Now multiple GPUs. What is a GPU? GPU is graphical processing unit. If you are using data which is having high graphics, you use multiple GPUs. tf.keras model can run on multiple GPUs using tf.contrib.distribution strategy. So you can use a particular strategy by which you can use multiple GPUs. So that is all about what is keras. Okay. Now, after this, we'll go back. Keras we have already talked about. We will talk about now keras already we have talked about. Under this we have used estimators, checkpoint, etc. etc. Now we have to talk about using GPUs. So in using GPUs, the supported device for keras, you can use CPU on your machine, GPU on your machine, second GPU on your machine, etc. by specifying these things. Okay. So that is all about using GPU. Then you can go for using TPUs. I am giving you an overview, but the specific topic we can come with a particular example. You can go for TPU estimator. Okay. Here we will go for cloud TPU because we have a proper method to sign in and we can use that. Now we come to low level APIs. What is let's come back to TensorFlow right, then from where we will go for that. So already we have discussed these things. Now we have to talk about low level APIs. So introduction to low level APIs. Low level APIs, actually we have to go for the tensor value. Now what is a tensor? Tensor is an element of multi-dimensional matrix. So first thing is computational graph. When you create a model, you get full graph. Computational graph is a series of TensorFlow operations arranged into a graph. The graph is composed of two types of objects, operations and tensors, right? Now simple, if you make a computational graph, it is simply, you can see a kind of type of data structure computation. If I am taking a constant float 3.0, another float 4.0, totaling it, then we printing it, printing B, printing total, so we get something. So if you execute it, you can see it on Tensor board. What is a Tensor board? TensorFlow provides a utility called Tensor board. I have an episode on this, what is a Tensor board. One of the Tensor board's many capabilities is visualizing your computational graph. Right. So it looks like this. When you have A and B, you are adding it, it looks like this. Okay. So simply, this is low level APIs. So you can go for some data sets, etc. Layers, creating layers. Now this is other than keras. As I told you that in keras you can write simply a statement and you get a layer. But if you are using low level APIs, you have to work more, you have to code more to create a layer. So that is the advantage of keras. Right? Now lastly, in this episode, we'll come to something called as ML concept. For that also, for this site is creating some problems, so we'll go to, firstly we'll go to the top, and then after going top, then we can go to ML basics. I have to click on guide again, then only it will show. So we'll go to ML concept. Embeddings, which introduce the concept of embedding, provide simple example of training and embedding in TensorFlow and explain how to view embeddings in TensorFlow. So we'll go to embedding. So you can see visual embedding here. You have different things, and this is your embedding data set. So this is all about embeddings. So here we have already given, and this introduction is basically for those people who have little knowledge about object-oriented programming, have little knowledge about neural network, have maybe basic knowledge of machine learning, have basic knowledge of Python. So if we sum up, in today's lecture we have talked about the website tensorflow.org. In that we have seen the option of signing in and executing Jupyter Notebook on cloud. Okay, and we have seen some beginner example. Okay, so you can have the homework that you can log into this website, sign in with your account, Gmail account, and execute the simple MNIST problem on cloud, or even you can do that on your machine by installing TensorFlow.